Hi students, welcome again to our YouTube channel. So today we will proceed the previous part of that paper like 2020. So here is part 2 and we will proceed from question number 3. Alright, okay, let's start. This question is about period 3 elements. Fig 2 shows the second ionization energies of some elements in period 3. So you can see here magnesium, aluminum, silicon, phosphorus and sulfur. You can see magnesium, aluminum, phosphorus and sulfur is present, but silicon is missing here. So the question is, draw a cross on fig 2 to show the second ionization energy of the silicon. Remember that the second ionization energy of the silicon that is present in between magnesium and aluminum, like you can say here, for example, magnesium is round about like 1350 and aluminum is 1800. So that is the intermediate between magnesium and aluminum. So that will be like about 1580. So it means you have to cross at this position. Okay, like I am going to write here, that is 1580, but you need to put the cross on the fig, not you have to write. Okay, next question, identify the element in period 3 from sodium to argon that has the highest second ionization energy, not first. So as you know that the second highest ionization energy that will be in period 3, that will be for the sodium, because for example here the first ionization energy like here is sodium ion, that will convert it into Na2 positive plus 1 electron loss. Why? Because you know that now the sodium ion has 8 electron in the outermost shell, so it is very difficult to eliminate one more electron. So it means that is the highest ionization energy. So you can write here sodium. Okay, now give an equation including the state symbol to show the process that occurs when the second ionization energy of this element is measured. If you are unable to identify the element, you may use the symbol Q in your option. So it means you can use here the symbol Q. For example, I am going to show you Q positive, that will convert it into Q plus 2, and here is 1 electron loss. So instead, as we already found, that is sodium. Okay, so we have to write here that is element sodium, and the equation we already write here. Let me move that. Okay, here is the equation. Alright, so that is the answer of 3.2. Okay, next question is very easy. Explain why the atomic radii decreases across period 3 from sodium to chlorine. As we know that when we move from left to right, the atomic size decrease, the atomic radii decrease. Why? Because here the number of proton increase, or you can say nuclear charge increase. Nuclear charge increase, that is the first reason. Okay, nuclear charge increase. And the second one, that is the electrons are added to the same shell. Electrons, I am going to write in negative, are added to the same shell. Okay, and you know that when the electron are added to the same shell, it means the shielding effect remain same. Shielding is similar. Okay, so that's why due to nuclear charge increases, so it means due to number of proton increases, so that's why the atomic radii decrease across the period number 3 from sodium to chlorine. Identify the element in period 3 from sodium to chlorine that has the highest electronegative. So as you know that when we move from left to right, the electronegativity increases. So it means chlorine will be the most electronegative atom or electronegative element in period 3. So here I am going to write chlorine. Okay. Now the next one, that is phosphorus burn in air to form phosphorus pentoxide. Like here phosphorus oxidation state is 5. So it means here it should be, the product should be P4O10. Why? Because here like you can calculate the oxidation state of phosphorus here. So that will be, here is like 4 into x plus 10 into minus 2 is equal to 0. Okay, so that equal to 4x minus 20 is equal to 0. It means 4x is equal to 20 and x is equal to 5. So that's why here we will use P4O10. So it means the product will be P4O10. Now here that the reaction between phosphorus and air, it means air means there is oxygen. So it means here is, we can use O2 and that react with, like phosphorus you can write 4p or p4. In both ways both are correct. Okay, I am going to write 4p plus 5 to, because here are 4 phosphorus, so that's why. And now we need to balance, so here now the equation is balanced. So that is your equation. Okay, next question. Question number 4, that is propanoic acid, that C2H5COOH is a weak acid. The acid dissociation constant Ka for propanoic acid is 1.35 times 10 to negative 5. Okay, at 25 degrees Celsius. State the meaning of the term weak acid. As you know that the weak acid, like the definition of weak acid, that slightly ionized. You just remember that slightly ionized, and you know that in the water to form hydrogen ion. In water to form hydrogen ion. Okay, it means that they are partially or slightly ionized or dissociate in the water to form hydrogen ion. Okay, next give an expression for the acid dissociation constant for propanoic acid. So here as you know that the propanoic acid that will convert it into propanoid, and the another one ion that will be H positive. So it means here that will equal to Ka is equal to H positive into C2H5, sorry, okay, so C2H5 COO negative over C2H5 COOH. Okay, so that is the expression for the acid dissociation. Okay, next, a student dilute 25 centimeter cube of 0.500 mole per decimeter cube propanoic acid by adding water until total volume is 100 centimeter cube. Calculate the pH of this dilute solution of propanoic acid. Give your answer in 2 decimal places. So first of all, here like we need to find the concentration of like the concentration of propanoic acid. Here is because that is in a diluted form, like a student dilute 25 centimeter cube of 0.5. So it means here we need to find first like the propanoic acid, that is okay. So here it will be C2H5COOH is equal to like 25 centimeter cube. Okay, so we will not convert it into centimeter like decimeter, because that already like you can convert. In both cases the answer will be same. Okay, let's suppose I am using the same. Here is 25 times 0.5 divided by the total volume, that is 100. So you got the answer will be 0.125 mole per decimeter cube. Okay, that is your first thing that you need to find out. Okay, now the next one, like we need to find, as you know that pH, like here pH is equal to negative log of hydrogen ion concentration. So we need to find the hydrogen ion concentration here first. So as you know here, like from the equation you can see here, like the propanoic acid will multiplied with Ka, and here are the two ions like hydrogen ion and C2H5COO negative. So it means here we will take as H positive square is equal to like Ka multiply by C2H5 COOH concentration, that is 0.125. okay, so now here the value of Ka is given, that is 1.35 times 10 to negative 5, 10 to power negative 5. So there will be 1.35 times 10 to power negative 5 times 0.125 and is equal to H positive square, taking square root on both sides. Okay, first multiplied it and then taking take square root, then it will be the H positive will be, let me calculate it. Okay, so that will equal to 1.30 times 10 to power negative 3. Okay, that will be equal in mole per dm cube. Okay, so that is the hydrogen ion. Now it is very easy, you can take the negative log of hydrogen ion concentration. So here that will equal to the pH will equal to negative log of 1.30 times 10 to power negative 3. Okay, so then the answer will be 2.89. okay, that is the answer. Okay, next question 4.4, that is related to buffer solution with pH of 4.5 is made by dissolving x grams of sodium propanoate. Here the formula is given in a solution of propanoic acid. The final volume of the buffer solution is 500 centimeter cube and the final concentration of the propanoic acid is 0.250 moles per decimeter cube. So first of all we need to find the hydrogen ion concentration from the pH. As we know that, like we already discussed, hydrogen ion concentration is equal to negative log of, the pH will equal to negative log of H positive. Okay, while the H positive will equal to, if you want to find the H positive hydrogen ion concentration from the pH, that will equal to 10 to power minus pH. Okay, so here you can write H positive, the hydrogen ion is equal to 10 to power minus 4.50. Okay, that is present here. So that will equal to, let me calculate it. So then the answer will be 3.16 times 10 to power negative 5, and the unit will be mole per dm cube. Okay, now the next one, the second step, you need to find the propanoid ion. Like for example, here it would be, as you know that like we already did, Ka is equal to like C2H5 COOH, like here we did. Here K is equal to H positive times C2H5 COOH divided by C2H5 COOH. So you need to multiply Ka times propanoic acid concentration divided by hydrogen ion concentration is equal to the propanoid ion, okay, concentration. Now here that will equal to, okay, so here it will equal to C2H5 COO negative, that will equal to, as you know, as we already discussed, that here the final concentration of the propanoic acid, that is 0.250 times, like the Ka value I think we already discussed, that we already used 1.35 times 10 to power negative 5. So again we will use over the P hydrogen ion concentration, that is 3.16 times 10 to power negative 5. Okay, so here 10 to power negative 5 cancel out. So now you can easily solve this. So then the answer will be 0.1068 mole per dm cube. Okay, that is your second step. Here I am going to indicate it, that is first step, that is second step. Okay, now the third step sorry, the third step, that you need to find the x grams of sodium propanoid. So here we have concentration and we also have the volume, so it means we can easily find out the number of moles. So it means here the n will equal to, like you know that n is equal to C times V, concentration times volume. So here the concentration is 0.1068 times the volume will be 500 centimeter cube, I think so. So we need to convert it into decimeter cube, that will equal to 0.5. Okay, so here n will equal to 0.0534. That is your third step. Okay, now the number of moles are given. You need to find the mass. Okay, so for the mass, as you know that mass is equal to moles times molar mass. So we need to find the molar mass of sodium propanoid, that will equal to 96. So it means we need to put here n is equal to 0. Okay, let me mark it 4th step, and here is the 5th step final. So m is equal to 0.0534 times 96. So it means here you got the answer, that will equal to 5.13 grams. So that is your answer. Okay, so here first you need to find the hydrogen ion concentration from the pH. Second one, that you need to find the propanoid ion. Then the third, that will be equal to, the N will equal to C times V. Okay, so because concentration is 0.1068 and the volume, that will equal to 0.5. The fourth step, that you have to put the values here in the formula, that equal to mass is equal to moles times molar mass. So here the answer will be 5.13 grams. Okay, next question is like, here is some complex formation take place, like some reactions of Al H2O times 6 and the charge will be plus 3 aqueous ion as shown here. Okay, like you can say give formula of white precipitate, like the white precipitate is unknown. I think C will also unknown and A is also unknown. So it means here I think you need to find step by step. Okay, first, that is the formula of B here. So first of all, like here is the observation and the equation as well. If you see in this case, like the carbonate ions are actually react with aluminum. So it means here that will produce carbon dioxide gas. So it means here the observation will be what? There will be bubbles formation. So it means I am going to write B bubbles. Okay. Now we need to write first equation, then we can easily find out the formula. Okay. First of all, here that is Al, that contain hexahydrate and the overall charge will be plus 3. Okay, it react with, let's suppose I am going to exclude sodium ion. So as you know that the carbonate ion will be -2. So here I am going to write CO3 -2 and here is plus 3. So we need to balance it. So it means there are, like you have to multiply here by 2 and here by 3. So it means here is 2 and 3. Okay. So it will produce, okay, so it will produce 1 carbon dioxide. Okay, let's suppose here are the 3 positive 3. So it means, and here are the 6 water molecules are present. So it means from here you can write Al OH, like here I am going to write OH2 or H2O, and OH3. Okay, because the charge is plus 3, so it means that will be OH is -1, so there will be 3 hydroxide that will be used in this formula. Okay, while the next one, that is, okay, here I am going to exclude that square brackets. Okay, now there are 2 moles of aluminum, so you need to put here 2. Okay, and the next one, that is like here are 3 oxygens and the total will be, you can see here 6 times 2 is equal to 12, 12 times 2 equal to 24. So it means 24 hydrogens are here, but here you can say 3 times 2 equal to 6, 6 times 2 equal to 12, and 12 and 3, that is okay. So here it would be, the first you have to eliminate carbon dioxide from here, CO2, and you can see here 3 carbon, so it means here it will be 3 CO2, that is actually over observation as well. And then the last one, there will be like 6 hydrogens left from here, so it means here it will be, and 3 oxygens are also left, so it means here is 3 water molecule loss. Okay, So what is the formula? The formula is Al H2O thrice OH thrice. Okay. Okay, now the next step. Calculate the formula of the complex ion C. State one condition needed for the formation of C from, like again the same formula that is used, again the same like the substance and sodium hydroxide. Okay, give an equation for this reaction. Okay, you have to write the condition for that. Okay, for the condition should be here the sodium hydroxide will be in excess form. Okay, then it can be able to react completely. Okay, so it means here is the condition that you can write excess NaOH. Now you need to write the formula, but for the formula you have to write like the first equation. So again there will be Al that is the substance. Okay, I am going to ignore the the metal ion like sodium, and here I am going to write OH. Okay, now it will produce, so you can see here are the three OH, and there will be like the 4 OH negative that will combine, because that is in excess form. So here that will combine to form Al OH4 okay, and now here is +3 charge, so it means there will be -1 charge. Okay, let me write in this way. Okay, and now here is the 6 water molecule loss. Okay, so it means you can write that the formula of the substance that will equal to AlOH, here is 4 -1. Okay, now the next one, deduce the formula of complex ion A. So there is complex Y because the ADTA used, I think so here, yes. Here are the 4 sodiums combining with the ADTA, so it means that there should be like the use of aluminum. Aluminum will displace the ADTA, but aluminum charge is +3, and here there are 4 sodiums are used, so it means here is like you can write Al aluminum and EDTA, and overall the charge will be -1. Okay, now the next one, 5.4, explain the use of an equation via solution containing again that substance aluminum hexahydrate +3 ion has the pH less than 7, because as you know that the less than 7 indicate there it must show some acidic property, like it must show some, like when it dissolve, when it dissociate, it will produce hydrogen ion. Okay, so it means that here will be like Al +3 will dissolve in the water or will dissociate in the water, and it will produce, for example here I am going to write Al H2O 5, and here is OH. Okay, and now the charge will be +2. Overall charge will be +2 because here is one hydroxide used, and now one hydrogen combined with the water molecule to form H positive ion, H3O positive hydronium ion. Okay, so you can see here the production of the hydrogen ion indicated that it like act as a acidic, it act as a acidic form, okay, or acid in nature. Or you can directly like you can write the equation that will dissociate, it will form AlOH6, and there will be like instead of writing H3O you can also write only proton like H positive. Okay, explanation like why it act as an acid, because explanation is the aluminum Al plus 3 like has a very small size, and high charge, you can see on its surface, and high charge. Okay, or you can say has a high charge density. Okay, so what happen, it weakens the OH bond in water, release the hydrogen ions. So it means here I am going to write it weakens the OH bond in water, actually in the water, okay, to produce H positive ions. Okay, now your answer is completed. Okay, now the next question is question number 3. Methanol can be manufactured in a reversible reaction as shown. You can see here the equation is also given, and there is like a double-headed arrow that is used, it means that will be in equilibrium state. So shown a partial pressure change with the time at a constant temperature. So here you can see, okay, draw a cross X on an appropriate axis of fig 3 when the mixture reached to equilibrium. So you can see here that is the equilibrium state, it means that is related to, that is parallel to time. So here I am going to write X on here, okay, or cross on the time axis. Okay, now the next one, okay, a 0.23 mole sample of carbon monoxide is mixed with hydrogen in a ratio that is 1:2 molar ratio and allowed to reach equilibrium in a sealed flask at temperature T. At equilibrium, the mixture contains 0.120 mole of carbon monoxide. So you can see here the mole of the mixture contains 0.120 mole and the molar ratio is 1:2. So it means that the hydrogen molar ratio, the hydrogen mole should be its doubled. So it means here is, you can write the next one, equilibrium in which the number of moles of hydrogen is equal to 0.12 multiplied by 2, that equal to 2.4, sorry 0.24. Okay, that is your first step. Now the second one, the total pressure of the mixture is given. Calculate the partial pressure and in kPa for hydrogen in equilibrium mixture. Okay, so first of all you can see that how much the total number of moles. So the total number of mole will be, like here hydrogen is 0.24 and the mole sample that will equal to 0.23. So it means that carbon monoxide, so it means the total will be 0.47. I am going to write the number of mole that is total, because when you add them, so that will equal to 0.24 plus 0.23, that equal to 0.47. Okay, now The next one, that is you need to find the mole fraction. Mole fraction is represented by like the x, or you can write here, I am going to write mole fraction. Mole fraction is equal to like the number of moles of the, like you can say here is the hydrogen divided by the total number of moles. So here I am going to write 0.24 divided by 0.47. So that will equal to, let me calculate it. So that will equal to here 0.51. Okay, so it means that is your second step. You need to find the mole fraction. Okay, now the third step, that you have to find like the partial pressure of hydrogen in kPa. Okay, so here the total pressure is given 1.04 times 10 to power 4 kPa. So you need to find the partial pressure of hydrogen. So that will equal to, let me calculate it. Okay, so that will equal to 1.04 times 10 to power 4, that is the partial pressure, the total pressure, okay, times 0.51 times 0.51, that is the molar fraction. Okay, mole fraction, that will equal to the partial pressure of hydrogen. So here is 0.53. The answer will be 0.5304 times 10 to power 4, or you can write like 5.3 times 10 to power 3 kPa. Okay, so that is your answer. Or instead of writing this way, so you can write 5304 complete. Okay, next is give an expression for the equilibrium constant Kp for this reaction, state this unit. So as you know that Kp will equal to partial pressure of methanol, because the methanol you can see here is the product. Okay, so then that will equal to partial pressure of CH3OH over partial pressure of, like let's suppose I am going to write PP, it means that is partial pressure, okay, of H2, and the molar ratio that is 2, so it means here I am going to get put the power 2 plus partial pressure of carbon monoxide. Okay, so you can see here in the equation as well, 1 mole of carbon monoxide and 2 mole of hydrogen, it will form like the methanol, that is 1 mole. Okay, now you can see here, let's suppose the unit is Pascal. Okay, the pressure unit is Pascal or kilo, like kPa. So it would be like, here are the total, like you can see here is Pascal power 3 on the denominator, and in the like you can say numerator there is only power 1. So it means that the Pascal should be Pa minus 2. Okay, or you can write the kPa, here I am going to write, or you can write kPa minus 2. Okay, so you just need to find out, like it's only allow any pressure to power minus 2. Okay, 6.4 is some more carbon monoxide is added to the mixture in question 6.2 here. Okay, so the new mixture is allowed to reach equilibrium at temperature T. State the effect, if any, on the partial pressure of methanol and on the value of Kp. So as you know that when the like you can say concentration of, like when the concentration of carbon monoxide is added to the mixture, so it means that the effect on the partial pressure of the methanol will increases. Okay, while what is the effect on the Kp? Kp is actually, like you know, that is the constant. So because like it increase the rate of forward or backward reaction equally by the same amount. Okay, so it means that the catalyst does not affect position of the equilibrium, so it means there will be not effect on the Kp, so you can say there will be no effect. All right. Okay, 6.5 is state the effect, if any, of the addition of the catalyst on the value of Kp for this equilibrium. So you know that there will be no effect of the catalyst on the equilibrium, because like maybe increase or maybe decrease, like just like here is the Kp constant, that will be no effect. The same happening for the Kp, because that is in equilibrium state, so it means the increase rate of forward and backward reaction equally. Okay, because that's the role of catalyst, that increases, like that enhance that like speed up the rate of reaction, so that will be equally in the equilibrium state, so it means here is the no effect. And explanation, you can write that catalyst does not affect the position of equilibrium. Why? Because it increase like rate of forward and backward equally, just like here is the constant. Okay, Kp. Okay, next. Okay, so in the next video we will continue from question number 7, and then our last question will be question number 11. So we will bind up in the next video that paper. Okay, so take care a lot. If you like our video, then kindly do subscribe and please share our channel. Thank you so much. We'll see you in the next video. Goodbye.